the inverse sine, cosine, and tangent functions. Recall, the graph of a function must pass a vertical line test. That is, every vertical line can touch or cross the graph at most once. So if we have a graph, in order that something is a function, every vertical line can cross it once. If we have a situation like this is not a function, right? Because vertical line crosses twice, not a function. Not a function. Number 2, a function is one-to-one if it passes a horizontal line test. That is, every horizontal line can touch the graph at most once, touch or cross. So a function is one-to-one if any horizontal line crosses the graph at most once. Okay, so this one is one-to-one, but parabola is not one-to-one because horizontal line crosses the graph twice. So this one is not one-to-one. So now we have a function has an inverse. If it is one-to-one function, a function has an inverse if it is a one-to-one function. The graph of the inverse is reflected by the line y is equal to x. So the situation looks like this. If my graph is right here, this is my f of x. Then I draw the line y is equal to x, so it goes through 1, 1, 0, 0, 1, 1, 2, 2, because the slope is 1/1. This is the line y is equal to x. Okay, so now if we reflect this is like your mirror. You do need to flip it over on the other side, and the graph will look like here. Okay, so this is your f inverse at x. We can see that those two graphs are reflected by the y is equal to x. Okay, that's the inverse. And the inverse exists only for a one-to-one function, because if you reflect, then the graph would not be a function. For example, if I have parabola, this function is not one-to-one. And now I would like to draw the reflection by the y is equal to x. If I draw the reflection, so it's basically I'm switching x with y's. That's the reflection. We can see the function is reflected. So this graph is not a function because it does not pass the vertical line test. So not a function. Some relation, but not function. So that's why the graph needs to be one-to-one. So in order that the graph is one-to-one, we consider only one part of this function. Consider just only like this. Then when you find the inverse, reflect by the y, well, this would be the inverse. We restrict the domain. The domain is restricted in order to have the inverse for those functions that are not one-to-one. So the inverse of the sine function. The inverse of the sine function. We know the inverse of the sine function is sine to the -1. It does not mean 1 over sine. No, this is note. Sine to -1 is not 1 over sine x. This one is inverse. The same we have f to -1, that's an inverse. We don't say that this is 1 over f. No, this is just inverse. Okay, so that's the notation. And now we know that the sine function has the S shape. Okay, 2 pi, here is pi. That's my sine function. This function is not 1 to 1. This function is not 1 to 1, because if I take the horizontal line, it crosses twice. This is not 1 to 1. So we do need to restrict. We need to cut one part and have the 1 to 1 function. So if I cut right here and right here, this part is 1 to 1, because any horizontal line crosses the graph at most once. You can pick up another part too, something that gives you the 1 to 1 function. You cannot pick this part because this bump is not 1 to 1. But the most common is this part. So we restrict the domain. What is this value? It's pi over 2. And what is this value? Is minus pi over 2. So we restrict the domain to minus pi over 2 to pi over 2. So the function is 1 to 1 and the inverse exists. And the inverse sign is denoted by sine inverse x. Okay, now we would like to graph this function. So consider the part sine x. Here is the value 1. Here is the value -1. Okay, and we only consider from pi over 2 to minus pi over 2. Okay, so now we need to find the reflection. This one is my sine x. This is my sine x restricted to the given domain. And now I need to reflect this. So I'm using the overheads. If I flip it over, here is my reflection. Okay, here is my reflection. So this graph, the red graph is my sine inverse. Red graph is my sine inverse. And everyone can clearly see that this one is reflected by the line y is equal to x. Okay, so now we would like to talk about properties. What's the domain? And what's the range of the inverse function? What's the domain and range of the inverse function? So x-axis is switched with y-axis. Okay, so what's the domain? Now we had from 1 to 1. Now here would be the value 1 up to 1, right? So domain of sine inverse. Domain of sine inverse is from -1 to 1, and range and range of sine inverse, how high it goes on the y-axis. On the y-axis it's more than 1, it's basically pi over 2 to minus pi over 2 to pi over 2. Okay. So now we get the values, we switch the x with y's. So now we get the values of sine and sine inverse. Okay, now we get the values sine inverse of 1/2, sine inverse of 1/2. Now we are using the chart. Let's make the chart. X sine x. So here was 30, which is pi over 6, 45, which is pi over 4, and then we have 60, which is pi over 3, and how was it? Over 2, over 2, over 2, and on the top was 1, 2, and 3, and we take square roots. Square root of 1 is 1. So sine is 1/2. So now sine inverse of 1/2 is nothing else but pi over 6. So this one is pi over 6. Okay, and similar way, we have the other ones. Sine inverse of root 2 over 2. Root 2 over 2 for sine is pi over 4. So this one is pi over 4. We take the values of sine and we get from the domain. Okay, then we have sine inverse of minus 1/2. Of minus 1/2. If we look at the graph, minus 1/2 is right here. So the value is the same what pi 1/2, except it's on the minus side. Okay, so in that case the value is minus pi over 6. And the same sine inverse of 1 and sine inverse of 0. So sine inverse of 1, we do need to look into the graph. Sine inverse at 1. Sine inverse at 1 has the value pi over 2. Has the value pi over 2. And sine inverse at 0, the red graph is 0. Sine inverse at 0 is 0. Now, for every function that has an inverse and for appropriate domains, we have the so-called cancellations formulae. So we have that f inverse at f of x cancels to x. And this roughly goes like this. If I had the set of x's, this is my f of x. So first I have this one x, this is my domain. And apply the function f, so I will get f at x. And then when I apply the inverse, goes backwards. So when I apply the inverse one more time, then I'm getting back to x. So the same situation goes for this. First I apply the function f, and then I apply the function f inverse, and I go back to x. That's why the cancellation is sine f inverse, and the function basically cancel out. And similarly, we have the same way we have f and f inverse at x. It's just x for appropriate domains. Okay, so we had the same. So we had the same for the sine inverse. So for sine inverse of sine x will be equal to x, but for the function inside, for the domain of the function inside, sine domain is all real numbers, but that the inverse exists, we restrict it to for x from minus pi over 2 to pi over 2. That was my domain for the inverse. You can think that this is minus pi over 2 to pi over 2. Okay, so the cancellation formula works for those x's. And the same way we have sine at sine inverse would be just x for domain of the function inside. So domain of the inverse is from minus 1 to 1, minus 1x and 1. And now we have example. Find the exact value. Find the exact value. Sine inverse. Sine at sine inverse of 0.5. So to use the cancellation formula, is my x, is my number in this interval from minus 1 to 1? Yes, it is. So this is this by the formula number 2. This one is just my x, which is just 0.5 by the cancellation formula. Example B, sine inverse sine pi over 7. This is pi over 7. So sine needs to be between minus half pi and 1/2 pi. So is pi over 7 is nothing else but 1/7. Is 1/7 less than half? Yes, it is. So by this formula, this is just my x. So this is equal to pi over 7. And the third example, we have sine inverse of 4/3 pi. So for sine inverse 4/3 pi, 4/3 is more than half. This one works for half, so it certainly is not exactly the value, but this one can be different value. 4 pi over 3rd exists, and this value is, we can use the reference angle sine. So basically what I'm trying to do now, I'm trying to find sine 4 pi over 3. We'll see that exists. 4 pi over 3 is right here, because this one is pi, and pi is nothing else but 3 over 3, right? So 4/3 is 1/3 more. So the reference angle is pi over 3. So the value is equal to the same. The value is equal, this value is equal to sine pi over 3 up to the sine. So add sugar to coffee. Sine in this quadrant is negative, because sine is only positive in the second and the first one. So then when we have that sine 4 pi over 3 is equal to negative sine pi over 3. If we look into our chart, sine pi over 3. If we look into our chart, sine pi over 3, sine pi over 3 is root 3 over 2. So this value is minus root 3 over 2. Okay, so then we have sine inverse, and then we would have minus root 3 over 2, and sine is only from minus 1 to 1, and root 3 is roughly 1.5, so this one does not exist. Because domain of sine inverse is from minus 1 to 1. So first we cannot use the cancellation formula, but that doesn't mean this value might be different value. It will not be the same as this value, but it can be different, but in that case it turns out that it does not exist, because this number is more than 1. Similar situation happened for the cosine inverse, the inverse cosine function. Cos inverse, and we do need to restrict the domain from 0 to pi, because as we know that the cos curve is the V shape, right? The cos curve is the V shape, so this curve is not 1 to 1. So the inverse would not exist. So we do need to cut it. So we restrict and we take only this part. We take only this part of the graph. So the graph of this function I'm gonna use the part that we have. So this value is 1, this value is minus 1, and we're gonna go from 0 to pi only. And I'm gonna reflect. So this value we had that this one is 1 and this one is minus 1. And now I'm gonna reflect. I'm gonna reflect by the x, y is equal to x, by the graph y is equal to x right here. So I need to flip it over. I need to flip it over and move it, because we are reflecting by the, right here. Okay, so the red graph is my cos inverse. The red graph is my cos inverse right here. And everyone can see that it is indeed reflected. It is indeed reflected by the line. It is indeed reflected by the line y is equal to x, y is equal to x. Okay, so this graph is sine inverse, cos inverse x, cos inverse x. So let's talk about domain. What's the domain of this function, of the inverse, domain and range? Domain of cos inverse. So domain is the window on the x-axis. Domain is the window on the x-axis where my graph is, and it keeps showing me that this one is from -1 to 1. So it's from -1 to 1, and then range of cos inverse. Range of cos inverse is the window on the y-axis. So we have from 0 up to right here, and it says pi. So it's from 0 to pi. And as before, we will find the values. So since we have the graph, we're gonna find the values cos inverse at -1. Let's find this from the graph. Cos inverse at -1, the height of the red function is 0. So this value is 0. And cos inverse at 0. Cos inverse at 0. What's the height of the red function? It's pi over 2. Basically, the x-axis will switch with the y-axis, and that's how we get the inverse. That's how we get the inverse stuff. And the same way we find the cos inverse of 1/2. We read from the chart that the value is nothing else but pi over 3, or cos inverse from √2 over 2, and the value shows up pi over 4. How do we know this? Because we know the chart. Because we know the chart. Here's my x, here's my sine x, and here was my cos x. So we had 30 degree. We had first 30 degree, then we have 45 degree, and then we had 60 degree. But we need to do this in terms of pi. So this one is pi over 6, pi over 4, and this one is pi over 3. Okay, so it was over 2, over 2, over 2, and on top was 1, 2, and 3. And we take the square root. Square root of 1 is just 1. And cosine was from the backwards. √3 over 2, √2 over 2, and 1/2. And tangent x, we divided those ones. So this one is 1, this one is 1 over √3, and this one is √3. So now cos inverse 1/2 is pi over 3. Cos inverse of √2 over 2 is pi over 4. And similarly as for sine inverse, we had the cancellation formulas. We had that cos inverse of cos x is equal to x for x's from the interval x belongs, that's the sign belongs, from 0 to pi from 0 to pi. That's the domain of the function inside. Cos has all real numbers, but in order that the inverse exists, we need to restrict the domain. And then the same way cos of cos inverse is x for x from the domain -1 and 1. And now we would like to find the exact values. Find the exact values. We have cos inverse of cos pi over 3. Cos inverse of cos pi over 3 is in this interval, so the cancellation formula applies. So this one is pi over 3. Similarly for b, cos inverse of pi pi cos inverse of pi, and this one cos inverse is from -1 to 1. Pi we know is 3.14, so it's too far. Even cos inverse does not exist because domain is only from -1 to 1, so this one does not exist. And then the third one, cos inverse of -1/3. 1/3. -1/3 is in this interval, so we can apply the cancellation formula, and this is equal -1/3. And then we have the inverse tangent function. The inverse tangent function. We have similar situation for the tangent function. If we recall the tangent graph, tangent has asymptote at halves. Tangent has asymptote at halves, and the tangent is increasing graph. Tangent is increasing graph. So general tangent is not 1-to-1 because the horizontal line crosses the graph twice, more than once. So we restrict the domain to from -pi to pi. Okay, so we do consider just one part of this graph, tangent inverse, and those are my asymptotes in pi/2 and -pi/2. And now we do need to reflect this by the line y is equal to x. By the line y is equal to x. So that was my original graph is like this, and now I need to reflect. I need to reflect by y is equal to x, and that's my graph. Okay, so the red graph is my tangent inverse. And then we would have those asymptotes right here. Okay, and it is reflected by the line y is equal to x. So let's find the domain. Let's find the domain and range. So domain of tangent inverse. Domain is the window on the x-axis. My red graph keeps going from -infinity to infinity, so all real numbers. And range tangent inverse x. Range is the window on the y-axis, so the range is right here. So we have from -half pi to pi. So this one is -pi/2 to pi/2. And similar way we get the values. Similar way we get the values. Similar way we get the values. So we would like to check what is tangent inverse at 1, what is tangent inverse at -1, what is tangent inverse at 0, what is tangent inverse at minus root 3. And the same way. So tangent inverse at 1, we get this from the chart. Here's my chart. Okay, tangent at 1 is what? Pi over 4. So tangent inverse is pi over 4. Minus 1 is exactly the same value except with minus. So this one is minus pi over 4. At 0, I don't have in the chart, so I'm reading this from the graph. Tangent inverse at 0 is nothing else but 0. Minus tangent inverse minus pi over 3. Minus pi over 3 is the same value as pi over 3. So we check tangent, pi over 3. The value inverse would be pi. Oh, tangent inverse of minus root 3. Minus root 3. So tangent at root 3 is nothing else but pi over 3. And similarly, we have the cancellation formulae. We have the cancellation formulae that tangent inverse of tangent x is equal to x for the domain of the function inside. For the domain of the function inside tangent, but tangent is restricted to minus half pi. For x in the interval minus pi over 2 to pi over 2, and tangent of tangent inverse is x for the domain of the function inside. So for x from the interval minus 1, the inverse domain is all real numbers, or all real numbers. So then we have find the exact values. Find the exact values. We have tangent of tangent inverse of 2 pi. Tangent inverse has domain all real numbers, so the cancellation formula applies. So this one is nothing else but 2 pi. Then we have b, tangent inverse of tangent x, tangent of tangent 1. 1 is between those two because this pi is 3, so it's roughly 3 halves minus 3 halves to 3 halves, and 1 is inside this interval, so this one is equal to 1. So this one is 1 by the cancellation formula. And now we would like to find another example 5, solve. So we have A. Solve each equation, the question says. Solve each equation. And we have 3 cos inverse at x is equal to pi. So first we isolate cos x. We need to divide both sides by 3. So I'm going to rewrite this cos inverse x is pi, and now I divide by 3, solve it for cos inverse. So what we have that cos inverse x is pi over 3. And now we get the value from the chart. Now we get the value from the chart. We look into my chart. Cos inverse is pi over 3. So what is pi over 3? So the value on the cos and pi over 3 is 1/2. So cos inverse of 1/2 is pi over 3. Because the question is cos inverse of what number is pi over 3? So cos inverse of 1/2. therefore that x is equal to 1/2. Similar way we're gonna solve b. We have -6 sine inverse 4x is equal to pi. First we need to solve it. First we need to solve it for sine inverse. So I'm gonna divide both sides by this number, divide both sides by -6, by -6. So this cancel out. And we have that sine inverse at 4x is minus pi over 6. So now we will have that this is not my x, but this would be my 4x is equal to what angle sine inverse of what number gives me minus pi over 6. So I'm looking to my chart and I'm checking sine and pi over 6. Sine and pi over 6 is 1/2. So this gives me the value of -1/2. This I'm getting from the chart. So now I need to divide by 4, divide by 4, divide by 4. This cancel out. So 4 is like 4 over 1. So x is equal to -1/2 times 1 over 4, which is -1/8. So x is equal to -1/8. One more, see. We have 4 cos inverse x minus 2 pi is equal to 2 cos inverse of x. So cos inverse we bring on one side, any other numbers on the other side. So this 2 cos inverse goes to that side. So we have 4 cos inverse x minus 2 cos inverse x is equal, this goes on the other side, to 2 pi. Now I can collect like terms. I have 4 of something minus 2 of something. 4 minus 2 gives me 2 of something. So 2 cos inverse x is equal to 2 pi divided by 2. This cancel out. So we have that cos inverse x is pi. And then we can kind of apply the cos of both sides. If I apply cos of both sides, then what I'm getting that x is equal to cos pi. I'm getting that x is equal to cos pi. And what is cos pi? Cos pi has value 2 pi right here, and pi is right here. So x is equal to -1. You can just take cos, and then cos and cos inverse cancel out for some by the cancellation formula. So we have x is equal to cos x. One more example. Find the inverse function f inverse of each function. State the domain of f and f. State the domain of f and f inverse. And we have a f of x is equal to 3 sine x plus 4. So domain of this function, let's find the inverse first. So first we write y is equal to 3 sine x plus 4. Then I swap x with y's. We interchange x with y's. So I will have x is equal to 3 sine y plus 4. Okay, and then we solve it for y. So we need to bring this over. So I have x minus 4 is equal to 3 sine y. Now we need to divide by 3. This cancel out. So I have sine y is x minus 4 over 3. And now we take sine inverse of both sides. Sine inverse of both sides. So then sine and this one cancel out. So we have that sine inverse x minus 4 over 3 is equal to y. So that's the inverse function. That's the inverse function. We can write this backwards, that y is equal, or f inverse at x is sine inverse. And now I'm gonna rewrite this over 3. I can write that this is 1/3 x minus 4. Okay, so domain of the original function, domain of f. Domain of f is all real numbers, but we do need to restrict the sine function in order that the function has an inverse. What was the restriction? Is minus pi over 2 to pi over 2. So that's the domain of my function f. Now, domain of the inverse function. We need to work this out. Domain of sine inverse is nothing else but minus 1 to 1. Now the function is stretched 3 times. The function is stretched 3 times. So this interval from minus 1 to 1 is stretched 3 times. So for sine inverse of 1/3 x, the domain is minus 3 to 3. Okay, now the domain has changed from minus 3 to 3. And now this minus 4 means that we are moving the graph 4 units to the right. So now we are moving this graph 4 units. So this minus 3 goes to 0 and then goes to 1, and this 3 goes to 7. So the domain of the inverse is nothing else but from 1 to 7. You do the transformation. You start with the domain of the inverse. You start with the domain of the inverse. And the domain of inverse is minus 1 to 1. And then we do the 1/3, that's the horizontal stretch. It's minus 3 to 1. And then we are moving 4 units to the right. One more example. Example B. We have f of x is equal to 4 tangent x minus 1. We need to find the inverse and find the domain. So first I'm going to write y is equal to 4 tangent x minus 1. Now I swap x with y. So we have x is equal to 4 tangent y minus 1. And now we need to isolate that tangent. Now we need to isolate the tangent. So bring this one over. So I have x minus 1 is equal to 4 tangent y. Now we need to divide by 4. So this cancel out. So we have the tangent y is equal to x minus 1 over 4, and take the tangent inverse of both sides. So tangent inverse of x minus 1 over 4, and tangent inverse and tangent cancel out, so this is equal to x. Okay, so I rewrite this backwards. Y is equal, or f inverse is equal to tangent inverse, and I'm gonna write this as 1/4 x minus 1 x minus 1. So now domain of tangent, what was the restriction that the inverse exists? Domain of my original function. The restriction was from minus pi over 2 to pi over 2. And domain of the inverse. Domain of the inverse. Domain of tangent inverse is nothing else but all real numbers. Now, if you stretch the graph 4 times and if you move it, it still will be all real numbers. So domain of f inverse is all real numbers.